In this video, we're going to talk about decimal to binary, octal, and hexadecimal conversion. We really have an example on the screen, so let's quickly jump into it. So I'll write solution. You have to convert 256 base 10 to binary. So to do that, we simply draw a table and then we write 256 here. Binary is in base 2, so we are going to be dividing 256 with 2. Next up, what will happen is we'll ask ourselves, how many times does 2 go into 256? Or in another form, we say 256 divided by 2. 256 divided by 2 is 128, remainder 0. You always write the remainders. We do the division again. So we say 128 divided by 2. This is 64, remainder 0. Then we do it again. So we 64 divided by 2, which is 32, remainder 0. Then we divide again. 32 divided by 2 is 16, remainder 0. 16 divided by 2 is 8, remainder 0. 8 divided by 2 is 4, remainder 0. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And then you come here again and say 1 divided by 2, it cannot go. So we stop our division and then we say 0, remainder. We bring this 1 down here, 1. So what will happen is I will pick our numbers from the bottom to the top. So that this would mean that 256 base 10, you can say therefore, is equal to, we count, this is 1 and then we have how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 and then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 base 2. Okay, so this is simply how to convert a decimal to a binary. Let's look at the second example where we are asked to convert a decimal to an octal. We still draw our table, so we write 256. If you're converting it to an octal, we'll be dividing by 8. So this will be 8. And then we say 256 divided by 8. That is 32, remainder 0. From here, we do it again. 32 divided by 8. That's 4, remainder 0. And then we go again. 4 divided by 8. Since we cannot get any 8 from 4, we simply say 0, remainder. We bring this 4 down. So this will be 4 here. Then we pick the numbers from the bottom to the top. This would simply mean that 256 base 10 is equal to 400 base 8. Okay, so this is how to convert decimals to octals. You simply divide by 8 to get to a number less than 8. And then you pick the number from the bottom to the top. Let's look at the third one. Now for the third one, we are asked to convert 256 base 10 to hexadecimal. We still draw our table and then we have 256 here. Hexadecimal is base 16. So we'll be dividing by 16. 256 divided by 16 is 16, remainder 0. Then we do it again. 16 divided by 16 is 1, remainder 0. 1 divided by 16 doesn't go, so write 0, remainder. Bring the 1 down here. You will pick the numbers from the bottom to the top, so that we have 256 base, you can say therefore 256 base 10 is equal to 100 base 16. Let's look at another extra example concerning hexadecimals. For the next example, let's convert 177 base 10 to hexadecimal. For you to really be able to solve any conversion from decimals to hexadecimals, there's a table you need to be aware of. This table, base 10, and then hex. This could be decimal. So for a regular numbers, we have 1 in base 10. That simply is 1 in hexadecimals. We have 2. That would simply translate to 2 in hexadecimal. This is consistent till you get to 9. So every number from 1 to 9 is the same thing for both of them. But when you have 10 in base 10, in hexadecimal, we write that's A. If you have 11 in base 10, in hexadecimal, write that's B. If you have 12 in base 10, in hexadecimal, write that's C. If you have 13 in base 10, in hexadecimal, write that's D. If you have 14 in base 10, in hexadecimal, write that's E. If you write 15 in base 10, in hexadecimal, write that's F. So F is the last one. If you want to make any conversion, you most likely have to refer to this table or understand that A relates to 10, B, C, D, like that. So for this example, if we are asked to convert this, I'll simply draw my table again. So this will be 16, and then I have 177 on the other side. So I'll be saying 177 divided by 16 is 11, remainder 1. 11 remainder 1. So then I'll come here again. We know that 16 cannot go into 11. So that means this is 0 remainder. I'll bring 11 here. So I'll write 11. Instead of writing 11, I'll write B. So this should be B. So I'll pick the numbers from the bottom to the top. And then that means that 177 base 10 is equal to B1 base 16. So that's it. That's how to convert decimals to binary, to octal, and to hexadecimal. If you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching.